This video has to do with pages 1 and 2 of your Chapter 8 notes packet. This unit we're going to be talking about exponents, and we're going to learn some rules to make simplifying exponential expressions easier. So the first rule, which you might have discovered on your preview homework, is the product of powers property. That says if I have two powers with the same base, so let's say a to the m, that's one power, times a to the n, another power, I keep the base and I add the exponents. Okay, so using that property, I'm going to go ahead and simplify these. I would like you at this point to show your work using the property. Later on you can kind of take some shortcuts, but in your notes please show your work. Okay, so I have the same base. I'm going to just add the exponents, and I'm going to get 7 to the 8th power. Okay, couple things to be aware of. When you have negatives, make sure if the base is negative, you need the parentheses. And if you have just a number by itself, you can assume that that's an exponent of 1. Okay, so go ahead and pause the video and try the next 3 problems, and then check back and make sure you got it right. Okay, looking at the problems, you should have gotten 9 to the 11th power. Again, a number written without a written exponent has an exponent of 1. Same thing happens if you just have x. That would be x to the first power. This one, we have negative 5 to the 7th power. We need the parentheses because negative 5 is the base. Remember, the exponent refers to what's immediately to the left. So in this case, what's immediately to the left is that parentheses. So everything inside the parentheses is impacted by the 6. So you got to keep the parentheses in your answer. And then the last one is just a to the 7th. Note all of these problems talk about writing your answer using exponents. Later on we're going to actually evaluate the numerical part, but we'll talk about that. Okay, the next property is the power of a power property. Don't worry too much about these names, although they actually do make sense. So here's a power, a to the m, and then I raise it to another power. And what I do there is I keep the base and I multiply the exponents. Okay, so if you want, go ahead and challenge yourself and try these. Use this power property, and this one is tricky. Okay, so make sure when you do check your answers that you carefully see what I wrote and adjust your answer if needed. Okay, pause the video. Okay, so check your answers. The key thing is you have to have parentheses in this answer. So the first one is just 2 to the 15th. The next one is parentheses negative 6 to the 10th, because negative 6 is the base. The next one is x to the 8th. And then this last one, you have to be very careful. The base, notice the parentheses, is y plus 2. And so it is then raised to the 12th power. We can easily do that. We're going to just leave it like that. We can't easily expand this. It is potentially possible to multiply y plus 2 times y plus 2 times y plus 2 times y plus 2 12 times, but it's going to get extraordinarily complicated. So using these exponent powers, at this point, we're going to just leave it like that. If there's something added or subtracted, you just leave it. You can't expand it anymore. It's not equal to y to the 12th plus 2 to the 12th. And here's a numerical example you might want to write down, kind of proving that it doesn't work. Okay, so pause the video if needed to write any of this stuff down, and then flip the page to the next, or flip the packet to the next page. Thank you. Okay, one more property for today. If we have a product such as AB and we raise that to a power, let's say n, it turns out that that's equivalent to the individual factors raised to the same power. So if I have AB all raised to n, it's the same thing as a to the nth, b to the nth. Okay, so we're going to go ahead and use that to simplify the following expressions. Now note, this is important. Unless the directions state to write your answers using exponents, when asked to simplify an expression, all numerical values should be evaluated and written in simplest form. Okay, so at this point, we're going to start evaluating those numbers. For this first problem, though, we want to use this product property just to kind of see how it works. So we're going to have 2 to the 5th times 3 to the 5th. Then 2 to the 5th, I'm going to evaluate that, so that's 32. 3 to the 5th is 243. And if I multiply those, I get 7,776. Okay, so that's what that would simplify to. This next one, notice the base is 9xy, so it's all raised to the second power. So each individual part is raised, so I have 9 squared, x squared, y squared. So that's going to be 81 x squared, y squared. And that's my simplified answer. Okay, a couple more. Notice, very important, these are different. Here the base is negative 4k. Here the base is 4k, and it's the opposite. So when I do this one, the negative 4 with parentheses is raised to the second power, as is k. And so negative 4 squared is 16, and then I have the k squared. Always put your number first as the coefficient. This one, I have the opposite of 4 squared k squared. So I have the opposite of 4 squared is 16k squared. And I can just leave it like that. So negative 16k squared is the answer. Okay. There are now some other problems down below example 4. They're all a little more complicated. So go ahead, give it a shot, pause the video, try them, and then make sure, check back, and make sure you kind of carefully follow my work and make sure you adjust if needed. Okay, I wrote up here, just going back to those original problems, that this is negative 4k all squared versus this is the opposite of 4k all squared. Jot that down if that helps you. Okay, let's look at these examples. So again, anytime I have parentheses and there's a power outside, that power impacts each thing inside as long as it's a product. So that 2, it becomes 2 squared, and then x to the 6th, because I multiply, x to the 4th. Now with the x's, I have the same base, so I'm going to add them. So I get x to the 10th, and I can evaluate 2 squared as 4, so my final answer is 4x to the 10th. On the next problem, I'm going to impact the 5x squared is all to the 4th power. So that's 5 to the 4th, x to the 8th. Realize this 5 just hang out there is like 5 to the 1st. So the same base, I can add them. I get 5 to the 5th, x to the 8th. I evaluate 5 to the 5th, and I get 3,125, x to the 8th. Okay, on the next one, I have negative 10 is squared. Make sure you put those parentheses in your work. I'm going to be looking at your work, not just your final answer. So I have negative 10 squared, n squared, then negative 4 all cubed, n to the 9th. Now I can evaluate the numbers. I put them in parentheses here just so I didn't think it was subtraction. When I simplify, these are just numbers, and I'm multiplying. So I'm going to multiply them. So 100 times negative 64 is negative 6400. And then n squared times n to the 9th, same base. So I add them, n to the 11th. And then this last one, I kind of showed a lot of steps just to kind of keep track of where those negatives were. This first negative sign isn't impacted by the 5. So I just have this negative hanging out here. Everything else is, so I put it in parentheses. I multiplied, so I have y to the 10th and z to the 15th. And then from the second part of the expression, x to the 8th, y squared, z squared. Then I broke it apart just in case to make sure you're aware kind of this negative is like a negative 1. So it's raised to the 5th power and x to the 5th. And then I just kept everything. Now I evaluated negative 1 to the 5th power is negative 1 times negative 1 times negative 1 times negative 1 times negative 1, which is just negative 1. I combine my x's, so x to the 5 and x to the 8 is x to the 13th. Y's, I add them, I get the 12. Z, I get 17. And then I can evaluate this. Negative 1 times negative 1 is just 1, so I don't have to write it. And I have x to the 13th, y to the 12th, z to the 17th. Okay, so your final simplified answer, the number should be simplified unless it's said to write in exponents. And you should have only one 1x, 1y, 1z raised to some power. So if you had by mistake like left it at this step, that wouldn't be fully simplified because you have an x to the 5th as well as an x to the 8th. So anytime you can simplify it more, you want to. Okay, that's it for the notes. Thank you.